all possible water saving and very ingenious solution. Let's see him, please, Ahmed.
Good morning to all. Today I'm going to speak about one of the biggest challenges facing the landscape projects, which is the water. I'll speak about the sustainable irrigation system and water management. Our subject for today will be based on three titles, which is the design, construction, and the maintenance. We'll start about some facts about the water. The world population is expected to increase from 5.9 billion to 8.9 billion by 2050. By 2025, it's expected that 3 billion people will live in the cities considered as a water stressed based on their population compared with the water ratio. The climate changes are estimated to change the available fresh water, and groundwater being used at a rate higher than the capacity of recharge. The effect of irrigation, landscape irrigation can increase average water use by over 100% during the hottest season. Water demand and water quality and habitats protection issues make water supply more expensive. Typical irrigation systems do not conserve the water. Doesn't work. The global water distribution, we have 10% used in the industrial use and 69% in the agricultural irrigation use and 21% in the municipal use, which is very clear that the major irrigation consumption, the major global water consumption is going for the irrigation system. The main points for today is the relation between the landscape design and the irrigation sustainability, using the different water sources, and the main considered water source is the treated sewage effluent. The professional sufficient irrigation design with using the smart control system, using the device, the intelligent irrigation control system, proper restoration during the construction and the maintenance after the installation. We'll give a quick hint about the U.S. Green Building Council, or the LEED certification. LEED is an organization established in 1993, non-profit organization based in Washington, D.C. The LEED is a voluntary certification giving you credits, or you have to collect some credits with that certificate. And it's an indication of your project sustainability and that you're environmentally friendly project or building. Why do we use the LEED? It's an instant recognition for your building or project, faster investment rate, lower use of energy, water and other resources, better for community and the environment, enhance your brand and establish you as a leader for the LEED buildings. This is the distribution of the credits for the LEED certification. We can see that 10 points based on the water efficiency and saving the water. We'll give two examples of the credits you can get by saving the water for the professional water management. That by reducing the outdoor water for the building construction and design, you can get 1 or 2 points by saving the water or having irrigation without having a landscape project without need of irrigation for a certain time. Also the water metering and observing the water to detect the leakages and monitor the flow can give you credits. There are many things in the field of the water saving could help to give credit in the LEED certificate, like using the recycled material, power saving by using the solar power or the VFD pump. Any thing could save water or energy will give you credits in the LEED certification. We'll go now to the professional landscape design, and the professional landscape design shall study from the beginning the availability of the water quantity, and also the water quality at the site. We need to find the resources before starting the landscape design, because the vegetation area and the number of plantation shall be based on the available water quantity. Also, the selection of plants should be based on the available water quality. I could have salt water or sweet water or TSE water. Based on this, the proper selection of the plant will give a successful project. Using the native plants is highly recommended in the landscape design for the projects, and I don't recommend to have the imported plants to the local projects. Also giving solutions like the hardscape solutions to use the gravel or the walkways or artificial grass and plants in some areas away from people, like the flyovers under the bridges or beside the highways. Nobody will be in contact with the plants there and will not feel will not feel the natural plants there. So it's recommended to have the artificial plants in the places and the locations away from the people. We have a sample here, the photo. It's Abu Bakr Siddiq Square. It's more than 200,000 meters square, and it's all planted with artificial grass, one of the most beautiful squares in Riyadh, and it's saving more than 3,000 meter cube per day by using the artificial grass. Smart landscape design and planning help to have successful irrigation system, and accordingly the successful irrigation system will help for sustainability for the landscape project. We'll go now to the irrigation procedures and we'll speak about the available water sources in Saudi Arabia. We have three main water sources, which is the underground water to get them by the deep wells, and we have the desalination of the seawater, or for the underground water also getting by the wells, and we have the treated sewage effluent, which is the most important source for us for the future of the landscape. The wells usually giving a limited amount of water, and usually gives salt water. We cannot use the sensitive plants with the deep wells water, and also the wells could dry up during the time, and the water quality could change according to the consumption of the water from the wells. The desalination also is not eco-friendly system. It's consuming power, consuming energy, consuming chemicals, and also doesn't give 100% treatment for the water. If you are desalinating 100 meter cube, you will get 60 to 70 meter cube sweet water, and you will have a rejected water with a very high salinity, and you need to discharge them to the drainage or to anywhere. You will lose 30 to 40% of your water with the desalination by the RO plants. So needs professional and skilled technicians to operate them, needs continuous follow-up and costly. It's not the best solution for us, but we can use it as an alternative solution if there is no other solutions. finally, the treated sewage effluent. Treating the sewage water is a must because we need to release them to the sea or to the wadi, and we cannot release them without treatment to avoid the contamination of the environmental contamination and the diseases. So treating the sewage water is a must, whether you will irrigate with them or you will discharge them and you will not utilize them. So utilizing the sewage water in the irrigation doing double purpose. You are discharging your sewage water and irrigating your plants. Has lots of advantages. There are minerals and the nutrition value of the water for the plants is very good, and we can also produce power and get the fertilizer from the treatment process of the sewage water. There are some considerations when using the treated sewage water, but we cannot compare them with the advantages we get from using the treated sewage water in the irrigation, like the microbial presence and expected odor in some stages of treatment. The treated sewage water could reach stages to be like the drinking water, but I'm talking about the center of the treatment processes. The total solvent is not like drinking water. It could be 800 to 1,000, but still better than the pure water from the wells. Can get impurity and no clear limit of the pH, but all of this consideration still not compared with the advantages from using the treated sewage water. The recommendation is to use the treated sewage effluent where possible, and big title, there is no future for the landscaping without using the treated sewage effluent. Small comment that don't rely on the expected flow or the estimated flow and the new plants or the new projects, because the population at the beginning could be not as expected. So if you can rely on the main city treated sewage effluent, it will be much better to get the amount of water as calculated, and also the winter season, which is the dry season for the treated sewage effluent, also to be considered during the design. It's better to provide alternative solutions or water sources for the project to guarantee the sustainability of the project. We'll speak now about the professional irrigation design to maximize the water saving and use the value engineering. Our target is to maximize the system efficiency, maximize the water saving, minimize the cost and energy use, have a durable system. There is a very important point in estimating the irrigation consumption for the ornamental plants. Many factors are there, and I believe that most of the project is overwatering the plants, and we need more researches about ornamental plants to get the crop coefficient and to irrigate the plants as per the requirement, not more than the requirement. Some factors for the plantation requirement of irrigation: plant sizes and canopy, root depth, plants species, microclimate, if it's planted in a shaded place or under building or direct under sun. Those all factors affect the irrigation consumption. Soil nature. Study the topography of the site, because usually the water goes to the lower areas. And finally, the evapotranspiration rate, which is coming from equation by multiplying the wind speed with the solar power and the heat and many other factors, and we can get them from the weather stations. Overwatering is a common behavior in most of the projects. Not all the plants need to be irrigated every day. This is a wrong behavior in the projects. All the plants are irrigating all the time, every day, and we can test the sites and irrigate every other day and keep the plants, and you will find the plants successful, the plantation successful without any problems. So we encourage the researchers to find the stress point of the plants and avoid irrigating every day. And we'll speak about some technologies which can help in this issue. Proper selection of the plants, of the equipment and the accessories for the irrigation design. There are many equipment starting from the water source, the tanks, the pumps. Oversizing could harm the project or could negatively affect the project, like the overestimation of the pump sizes could give fluctuation of the pumps run and off, which is not good for the pumps. The tanks also, you need to estimate the volume of your tanks, the materials you need. If any features in the equipment or in your devices unusable, you will just lose money without any benefit, and it could also affect the project negatively. So we will speak about the selection of the device, and we highly recommend the design to be given to the experts to make it, and use the software and the modeling software to get accurate results and analysis for your design. This drawing is very important about what the desirable water and the undesirable water. We have the water, for example, it comes from the rain, or it's just a sample, but it's coming from the irrigation devices. We need to, our target is to give the water to the root zone to avoid the evaporation and the runoff and the deep drainage under the roots. The proper selection of the devices will help us to do some of these points. We have the centralized center control system and smart irrigation control technology. We have the automatic shut-off devices. We have the high-efficiency nozzles, pressure regulating devices, stick valves devices, and non-potable water devices. The central control system has many features, can avoid the overwatering, like the water station. Water station is doing the equation for the evapotranspiration rate and gives us daily irrigation rate according to the water change. By using the smart control system with the water station, we can save lots of water, as shown here in the graph. The blue area was a wasted water if we are typically irrigating the plants every day with the same amount of water. Using the smart control system would save this much water. The automatic shut-off device, we have the rain click to stop the irrigation during the rain, and the water station reducing and controlling the irrigation daily as per the different factors, the different factors of waters, increasing or decreasing the irrigation. We have the moisture sensor for the soil, which I also highly recommend to use them, because most of the projects are using only the weather station, but they are not sensing the moist at the soil. Also, the flow meter with the central control system can detect if there is any overflow or a broken line and directly close the branch which has the problem. High efficiency nozzle provide more uniform distribution irrigation to the plants, and also saving the water by 30% water saving. Pressure regulating devices. We have many samples for the pressure regulation. We can have pressure regulator on the solenoid valve itself, or we can have some devices pressure compensated or pressure regulated. It minimizes or control the flow with the different pressures, and also if there is any broken sprinkler or broken line with the pressure compensating sprinkler, this much water will waste. But sorry, without the pressure compensation, you will find this much water, and with the pressure compensation, you can find less water wasted during the breakage, and also the flow meters can detect the broken lines and give alerts about them. The high pressure gives us very small droplets of water. They could evaporate quickly, and also they are very light. They can go out of our target planted area to the walkways, and using the pressure regulator or the pressure regulated devices also helps to have the proper size of droplets go to the target. The slope area, we can get drainage or leakage through the devices in the slope area because of the negative positive pressure coming from up to down. We have some devices with check valve to avoid the drainage in the lower areas. The non-potable water, this is one of the considerations when we use the treated sewage effluent. We have to use the special equipments which can tolerate the chemicals and the high chlorine, and also it's equipped with a special type of filtration to can work with the TSE water without any problems. The distribution of the equipment, the selection is part of the design, but the proper distribution and location of the devices is the second part. If you miss the proper distribution, you will also lose big amount of water, and you will not get the expected landscape effect. Poor uniformity leads to longer runtime and more water flow. We'll go to the construction. Some considerations about the construction. Before starting the construction, to have a successful project, investigate your site and coordinate with the other utilities before starting the work. Get the required permissions and approvals from the related authorities and agencies. You could start the project and stop for any reason if you didn't get the permissions earlier from the authorities. Follow the manufacturer recommendations and the specs of the project. Don't proceed to the next step unless you pass the test. There are some steps and method of statement during installation and construction of the project. Don't go to the next step unless you pass the test. Like if you are doing a pressure test, don't backfill the pipes unless you pass the test. And also, the final indication of the test is the final testing and commissioning. You can do a partial test for some lines, but when you connect them all together, you will have a problem during due to the improper connection between the lines. The maintenance, operation and maintenance also is a very important point to keep your project sustainable after the construction. We highly recommend to follow the operation and maintenance instruction from the manufacturers, and the monitoring of the system by the SCADA and central control system could help you a lot to avoid the human mistakes. Preventive maintenance could minimize the corrective maintenance. If you are doing the periodical preventive maintenance, you will minimize the corrections and the mistakes at the project. You need to record your maintenance processes and have a list with the history of the maintenance and have the maintenance card on each equipment. Finally, Engineer Muhammad spoke about the weather station and said it was unuseful. It was unuseful because it's not utilized. So you have to do an auditing system and quality assurance system for your maintenance and follow up the maintenance procedures to guarantee that everything is done properly. There are inspection lists and auditing system to follow up your maintenance. The last point, this is a sample of checklist for irrigation maintenance system. The last point is the auditing of the existing projects. If you have an existing project, it's not too late. You can have an audit from some experts, and the Irrigation Association already have a course of landscape irrigation auditing system. You can audit your system and repair and solve any issues to make your system perfect. There's also a certificate for the irrigation auditing system. I advise all to ask the experts and to do the design by the experts. We have the suppliers and the manufacturers everywhere. We have our colleagues here from Hunter. They can support you and give you the last updates about the products. The solution is not limited to what I have mentioned. Those are samples, but you can get the other solutions, and you can get more information from the suppliers and the experts in this field. Thank you.